Alright class, welcome to another lesson. Today's learning goal is I can evaluate algebraic expressions when given what each variable represents using order of operations. Please write this at the top of your worksheet. I know there's no specific spot to put it, but find the spot in the middle where there's empty space and please write down this learning goal. Let's get started. So our goal is to evaluate an algebraic expression that has come up with a specific number for an algebraic expression when given what each number represents. And so the first question is b times b minus a, using a equals 1 and b equals 4. I'm going to show us two different ways to do this. Okay? The first way is to simply plug in the numbers as they are in here. So b is 4, so we're going to have 4 times 4 minus 1. So we follow order of operations. We do what's inside the parentheses first. 4 minus 1 is 3. We have 4 times 3, which is 12. Another way we could do this is to first distribute. Inside of our algebraic expression, simplify the algebraic expression. We got b times b, which is, let's first change this into plus minus. So we got b plus minus a, then we get b squared plus negative ab. So b squared would be 4 squared plus negative 1 times 4. So we have 4 squared, which is 16, plus negative 4, which gets us our 12. So let's take a look at another example. Number 3. Here we have nothing to distribute, we have nothing to simplify in terms of just the algebraic expression. So we're going to simply put it in over here. So j is 1, h is 2, so we have plus 6 times 2. 1 plus 6 times 2, we do the 6 times 2 first. 1 plus 12. 1 plus 12 is 13. Notice how this is very useful, especially when we're trying to figure out if we did distribution correctly. Okay? What we can do is first plug in some random numbers into here, different numbers for a and b, of course, so that we have some differentiation between the two variables. Simplify it normally, and then find out if our distributed work gets us the same answer once we substitute in. Okay? This can be done with the calculator to check our work. Let's try number 5. I'm going to show the two different ways here we can distribute. Okay? But let's try the first with the normal way by just plugging in m equals 5. 5 minus 6 minus 6. Again, we have 6 minus 6 in the parentheses, so we're going to make that into a 0. 5 minus 0, as we all know, is 5. The other way is to distribute and go from there. So we have m plus negative 1, p plus negative n. And we distribute the negative 1 in there. We get m plus negative p. This negative 1 times here. This negative n gets us a positive n. So again, m is 5 plus negative p is negative 6 plus negative 6. 5 plus negative 6 is negative 1, or excuse me, this is going to be 6, excuse me. 1 plus 6 is our 5 that we get back here. Okay. These are fairly simpler ones. Remember to follow order of operations to make sure that you're doing it correctly, especially take a look at this one, you need to follow order of operations. Let's try one that's a little bit more complicated that uses a few more steps. Here we could, this here we wouldn't distribute because this is, even though there is distribution here, we would still follow order of operations first. Okay? So please be aware of that. Make sure that it is a full term by itself before distributing. So here we can only use the substitution method directly. So y is negative 5 minus 12 divided by 6 times y again is negative 5 minus negative 19. So we will go from there. We will do what's in parentheses first. Negative 5 minus negative 19. Remember, we have said that we are going to try and do addition of the opposite. So negative 5 minus 12 divided by 6 times negative 5 plus addition of the opposite of negative 19, which is 19. Negative 5 plus 19 is going to be 14, so negative 5 minus 12 divided by 6 times 14. From this point on, we again need to follow order of operations, which means that we're going to do division, and then the multiplication, and then the subtraction. So, 12 divided by 6 is 2, negative 5 minus 2 times 14, then we do 2 times 14, which is negative 5 minus 28. Negative 5 minus 28 is, again, the same thing as negative 5 plus negative 28, which gets us our negative 33. Go ahead and try number 9 on your own. We'll come back together and take a look at it, and please observe that these are absolute values. If you did it correctly, you should have something like the following, where you substitute in over here. This is negative 14 plus negative 14 minus negative 13 minus the absolute value of negative 13. Here I simply changed it from subtraction to addition of the opposite. So plus 13 instead of minus negative 13. And I took the absolute value of negative 13, which gets us 13. Combine negative 14 plus negative 14, negative 28. Negative 28 plus 13 is negative 15. Negative 15 minus 13 is negative 28. Notice how this is also very valuable when we're combining like terms. We can combine like terms right here. Please do not combine these like terms because this is an absolute value. Okay. We can only combine it if they're not inside parentheses or absolute values. So, this would get us 2x minus y minus the absolute value of y. And notice how if I were to substitute, it'd still be 2 times 14 minus negative 13 minus the absolute value of negative 13. Again, we change the addition of the opposite. 2 times 14 plus 13 minus 13. This is 28. Plus 13 minus 13, which gets us back to this one right here. Excuse me, this is negative 14. This is negative, negative, and negative. So that gets us back to this line right here, which then further simplifies down to negative 28. Go ahead and try the rest of the worksheet on your own. You have the answers to all the odd problems, so try those first, check your answers, see if they make sense, and then go on to the even ones.